Hello, beautiful people, and welcome. In today's video, I'm going to go through the practice test for the chapter 8. These are going to be two videos. I'm going to do part 1 in one video and part 2 in the other one. Now, I will not be doing all of the questions, but I am going to walk through as many as I can. Okay, let's go and start with number 1. When it's asking you to find the measure of each angle, you are going to take a look first if the given information is in radians or if it is in degrees. So since we notice that this section right here is 5 pi 18ths, this is in radians. So that means your answer needs to be in radians. This is not the answer, okay? This is not the answer, but the answer needs to be, okay? So then we're going to take a look, is this a positive or a negative angle? Okay, am I going up or down? We're always going to start from our initial ray, so this is our start. Then notice that from our start on the inside, we have this, I'm going to color code it in pink, one full cycle. Now, how did that cycle happen? Well, we went up. So that means that our answer is going to be in radians. It's also going to be a positive angle going up, right? We went up. And then you start calculating what the distance traveled. So since I traveled one full cycle, that means I have traveled 2 pi. And I then traveled this quarter. And a quarter is pi halves. And then I traveled this section here, 5 pi 18ths. And so that 5 pi 18ths is that very last distance that we've traveled. That's the distance that they've provided. So if we take a look at what we have, let me actually write given. We're looking at 2 pi plus pi halves plus 5 pi 18. So we're going to put a 1 underneath 2 pi, and you're going to create common denominators with everything. So here I'm going to multiply top and bottom by 18. Here I'm going to multiply top and bottom by 9. So what we actually are doing is we have 18 times 2, which is 36. 36 pi over 18 plus 9 pi over 18 plus 5 pi over 18. Now I want to point out that this is a no calculator section. Okay, so you will not be having a calculator for this. So using your fingers to count is absolutely okay. Or you can do kind of off to the side, vertically 36 plus 9 and then plus 5. That's totally up to you. But we end up getting 50 pi 18ths. Now remember, we do need to simplify. So we're going to be dividing top and bottom by 2. So then that means that the size of the angle total, the actual answer, is going to be 25 pi ninths. Okay, moving on. Now, very similar to this, kind of like backwards problems, this one's asking you to draw the angle and then find the reference angle. So what you're going to do is you're going to take a look, is this in radians or in degrees? So number 2 is in degrees. And you're going to first split up the angle. Oh, keep moving this. By looking, is this a positive or negative? This is negative. That means we're going to be going down. And notice that this 335 is really close to 360. Okay. We can do kind of like an overshoot of that if you wanted to. and then backtrack it that 25 degrees. So I'll show you two options. So we can go 360, which is too much. This is a full cycle. And then remove from that our 25 degrees. Okay, this is option number one. This is too much. And this is, we're going to remove a little bit. This is not a quarter. This is less than a quarter, not even half a quarter. It's just a little bit. You could have also done you can go by quarters if you want. So you can go by like 90. You can also say I have 180 in here. You can go 270 if you want, plus a 90 in here, which is our 270, which is our, if we're thinking we're past quadrant 3. And then how much more do we need? Well, we need 65 more. Remember, this is a half a cycle. This is a quarter of a cycle. And this right here is more than half of a quarter. Okay, this is more than half of a quarter. So how do we know what's half of a quarter? Well, a quarter is 90 degrees. Half of that is 45. 65 is obviously more than 45 degrees. Okay, so translating this in English helps us draw the angle. So let's go ahead and do that. Now, the objective is also to find the reference angle, so I kind of have to make this work here. It's going to be a little on the smaller side. Are we going up or down? We're going down. And again, you have two choices. If I'm looking at the purple, I'm going down half, 90, and more than half of a quarter. So I'm about here. Okay. And so then the actual question, so this is part one, you've drawn the angle. And then the second part is, what is the reference angle? Now, reference angle must touch the x-axis. You have one of four options, but from the x-axis or the negative x, you can go up or you can go down. So this angle right here, that's our reference angle. And it's asking you, well, what is this size? Sometimes you can get lucky. Like if we take a look here, it kind of already gave us the angle. But if we are looking at the purple and we've traveled 65 degrees, which is here, this here is 65 degrees, how much more do we need to get that quarter of a cycle? And that obviously is going to be 25 degrees. So, okay, so the reference angle is 25 degrees. Okay, similarly, we are doing radians now. So the objective is still the same of drawing the angle, finding the reference angle. We're still splitting up that angle. However, now we're dealing with radians, so different units of measure. Let's go ahead and start by asking, are we going to be going up or down? Is this positive or negative? This is positive. So we're going to be going up. When we split this up, I usually like to write a plus in the beginning of my brackets. And you can do this off to the side if you like. You have your 2 pi, your pi, and your pi halves. Now this is just a reference for a full cycle, half a cycle, and a quarter cycle. And the reason I'm doing that is because we need to create common denominators. Common denominators with the given angle. Now, our denominator is 3, right? So how do we create, I'm looking at this quarter, a common denominator between a 3 and a 2? Well, common is going to be 6. So that means not only do I need to change all of these to have a denominator of 6, notice how I'm putting a 1 underneath, I am also needing to change my original angle to 14 pi 6 in order for me to be able to do my calculations. So 6 times 2 is 12, pi over 6. Here we got 6 pi over 6. Here we got 3 pi over 6. Now that we have common denominators, again, we're changing our original because we need common denominators. We can now use these values right here to add up to 14. So immediately my eyes go to 12. 12 pi 6 plus 2 pi 6 gives me 14 pi 6. Now what is 12 pi 6? 12 pi 6 is a full cycle. What about 2 pi 6? If I take a look at my quarter, this 2 is really close to 3. Now, what is half of 3? Half of 3 is 1.5. So this is less than a quarter, but more than half. So more than half a quarter. And translating it like this in English is going to help you in your drawing of the angle. Again, let's make this a little on the smaller side. We are going down from our start, from our initial ray. Just kidding. No, we're not. I looked here. We're here. We're going up. Up a full cycle. So here's a full cycle. Then we're going more than half a quarter. We're about here. Okay. Now, once again, this is giving you a reference angle in quadrant 1. That does not always happen. Please understand that that does not always happen. It can be a reference angle 1, 2, 3, or 4 as long as it's touching the x-axis. Okay, so our reference angle is here in quadrant 1. And again, we're looking at the size of this. So what is its size? Well, we got lucky in this question on the way that we broke apart the original. So we already know that this distance traveled is 2 pi 6. Always simplify. So that means our reference angle is, simplify this, pi thirds. I want to stress, if they are giving you something in radians, you must give your answers in radians. Please do not convert to a decimal. That will give you no credit. Okay, find the value of the trig function indicated. So if you are seeing 1 of 6 or 1 of 3 of these, secant, cosecant, sine, cosine, tangent, this right here is telling you you have a right triangle. So you're looking out for these keywords. So if you have a right triangle, go ahead and draw the right triangle. How you draw it doesn't matter as long as it is a right triangle. And they're not necessarily telling you what A, B, and C are, so we can label it however we want, as long as C is always your right angle. C has to be. So I can label this A and A, this B and B. Now, what they are telling you is that secant of theta, so again, theta is our choice where to put, is 5 over 4. So you can put theta on top, you can put theta on the bottom. I typically select A for theta. So that means this is my opposite and this is my adjacent. You can remove your A, B, C's. That's technically not necessary. But here we are. Okay, secant of theta is the reciprocal of cosine of theta. And if we recall our SOHCAHTOA, cosine is adjacent over hypotenuse. So when we go back to secant, secant is now hypotenuse over adjacent. Okay, why is that important? Because we already know that secant is 5 over 4, which means our hypotenuse is 5, our adjacent is 4. Our adjacent is 4, our hypotenuse is 5. Now, if you know your Pythagorean triples, you should already know what your opposite is, which is fine. If you don't, that's okay as well. You can solve for your opposite side. You can put back this A here if you want. A squared plus B squared equals C squared. A is unknown, right? That's our opposite. We don't know what that is. B is going to be our adjacent 4. And again, this is a no calculator section, so the numbers are going to be on the smaller side, or they're going to be Pythagorean triples. And then we go ahead and calculate. So a squared plus 16 is equal to 25. Subtract 16, subtract 16. We got a squared is equal to 9. Take the square root, make it positive. Oops, and that's going to be 3. Again, here in green, you did not need to do this if you know your Pythagorean triples. Now that we have our triangle, we're going to take a look at what it's asking us. It's asking us the question for cosecant of theta. Cosecant is the reciprocal of sine. And if we again take a look at SOHCAHTOA, so opposite over hypotenuse is sine of theta. So when we go back to cosecant, we're talking about hypotenuse over opposite. So that means for our final answer, make sure it's simplified if possible. Our hypotenuse is 5, our opposite is 3. This here is our answer. Okay, moving on. Okay, this one is asking you to graph. This one is asking you to graph sine and cosine. I'm going to do obviously one at a time. So let's go ahead and identify some information. I'm going to do again one at a time. I usually like to draw lines. This is going to be a positive function. What kind of function is it? It is a sine. The characteristics of a sine is it starts, stops on the midline. And because it is positive, we are going to be going up first. Next, we're going to identify our amplitude. Our amplitude is going to be the absolute value of our A value. Sorry, the absolute value of A. And then at the very end, we have our midline. And that's going to be our K value. Now here in the middle, we want to factor out our B value. So what we have right now is 4, I'm going to change it to x, minus pi thirds. And what we need is we need to pull out that 4 and create this h value. In order to do that, you're kind of going to create a mini equation, and you're going to take out that 4 and take its reciprocal. So when we flip 4, it becomes 1/4. Then you're going to take the original value that they've given you, exactly how you see it. So this is pi thirds. And together, when you multiply straight, that gives you your value for h. So this is pi 12ths. Remember that after this process, right after you have factored it out, you want to rewrite the equation because that's the one that you're going to use to continue with your graphing. So after this, we're going to write 4 times y equals sine of 4 of, I'm going to change mine to x, minus negative pi 12ths, close it, plus 2. Again, we already know certain things. We know this is going to be positive sine. We know the amplitude is the absolute value of 4. And we know our midline is 2. Now, from our factored form, there's going to be 2 more values. This b value you're going to use to find period. This is not your period. This is used in this little mini equation, 2 pi over b, to find your period. So how does that look like? We have 2 pi over 4. 4 is our b value. We're going to put it in the denominator. And then simplifying that, we get pi halves as our period. Next, from the equation, we're going to acquire your start value. This is called your phase shift. And it's always opposite of what we see. So we see a negative. We're going to start at a positive pi 12ths. Two items that we need. Actually, one. We already did the period. So we need an end value. No, two. We need an end value and we need our distance. Our end value is going to be your start and your period added together. So we got our period of pi halves plus our start at pi 12ths. I'm going to do common denominators, multiply this by 6, so we get 6 pi over 12 plus pi 12. So it looks like our end value is going to be 7 pi 12ths. And then our distance is going to be our period multiplied always by 1/4, and it's always going to be that 1/4. And we get pi 8ths. Unfortunately for us, that did not give us common denominators for your start, your end, and your distance. So all of these need to have common denominators in order to help you. So we are going to change this to 24. Now you can do this now, or you can do this like when you're working on the equation. It's completely, sorry, not the equation, the graph. So it's completely up to you if you want to do your common denominators here or you want to do it later. So I'm going to show you how to do it later instead of changing them now. I'm going to go ahead, looks like I'm running out of space. I'm going to go ahead and graph separately. My start is at a positive, my end is at a positive. So it looks like we don't need negative x's. And my midline is at positive 2 with an amplitude of 4. So kind of a little bit lower. Let's pretend that is a straight line. All right, so where are we starting? We're starting at 1 pi 12ths. This is not an asymptote. This is just a start. This is going to give us an idea of where one period, one cycle, one revolution is going to be. This is our end at 7 pi 12ths. Okay, so what I mean by common denominators, you can do this in two different ways. You can convert this to a denominator 24 and then just add. Or you can start with your start value of pi 12ths and add your distance to it of pi 8ths. When you do this separate little equation, this is going to give you your common denominators and give you your next x value. So I'm going to multiply this by 2. I'm going to multiply this by 3. Remember, this is still in the no calculator section, so you're not going to be using calculators for this. Your basic multiplication should be done without a calculator. So we get 2 pi over 24 plus 3 pi over 24. So we get 5 pi over 24. This here, you're going to write it as your next value, and that's going to be 5 pi over 24. If you can simplify, go ahead and simplify. Right, this one cannot. We're going to pick up that value, 5 pi over 24. We're going to again add our distance. And you're going to keep doing this pattern until you get a total of 5 points and you've reached your end. Again, common denominators with your distance, we get 5 pi over 24 plus 3 pi over 24. 5, 6, 7, 8 pi over 24. Again, this is where we need to simplify. And so we get pi thirds. This is your x value that you're writing in. Okay, next we are taking, again, you have a choice, either take the pi thirds or take that 8 pi 24ths. I'll take the pi thirds at our distance of pi eighths, again, common denominators. Multiply this by 3, multiply this, by 8. We get 8 pi over 24 plus our distance of 3 pi over 24. 8, 9, 10, 11 pi over 24 is our next x value. And at this point, you can choose to stop. I am going to do one more to double check that our end value is correct and that our distance is correct. So we're going to take that 11 pi over 24. We're going to add to that our pi eighths, common denominators. We get 11 pi over 24 plus 3 pi over 24. This is 11, 12, 13, 14 pi over 24. And we're going to simplify, divide that by 2. We get 7 pi 12ths, which thankfully is my end x value. So again, you could have changed all of your common denominators here, or you can wait and do it here. But again, you will not have a calculator for this portion of the exam. So now that we are back, I went ahead and written out our x values. I'm going to go back to the equation. Finding our midline is at 2. Okay, none of these are asymptotes. These are just markers to help us graph midline. Then our A value is 4. So that means I'm going to go 1, 2, 3, 4 jumps up. This is going to be my maximum value. So 2, 3, 4, 5, 6 is my maximum value. And then we're going to go 1, 2, 3, 4. And negative 2 is going to be my minimum value. And now we've created this section right here, this rectangle, that this is going to be one cycle, one period for this sine wave. So we're going to start, end, and have our middle on the midline. So not on the x, but on the midline. Start, end, and your middle is on the midline. Next, we are having a positive function. So this middle of the middle is going to go up because it's positive. That means we're going to be increasing. And then this secondary middle of the middle is going to go down to our minimum value, kind of like having an S pushed over. No jagged edges. If it looks like a V, points will be removed. This is smooth. Always use a pencil in this here. And now these are not asymptotes. So that means we will be touching and we will be crossing our start and our end. This is just one loop-de-loop on the unit circle. This is just one cycle. So we are going to extend with an arrow and extend downward with an arrow. Arrows are required. This is a continuous function. It will always have your smooth wave continue and always and always and always. Okay, let's go ahead and do one more, and that's going to be our cosine. And for cosine, I'm just going to rewrite it on a sheet of paper instead of writing it on the paper that is provided. This is question number 6. Question number 6 is y is equal to 1/2 times cosine of 3, I'm going to change it to x, plus pi halves, close it, minus 1. Okay, let's go ahead. You can identify things now or you can wait. I'm going to factor out your b value. So what we have is 3x plus pi halves. And what I need is to bring that 3 out and find what that value is here. The trick is you're going to take that b value, take its reciprocal, multiply it by the original value, and the original value is pi halves. Multiply that straight, and we get pi 6. Okay, let's bring that up, positive pi 6. Please do not forget that at this point you do need to rewrite your equation. I'm going to separate this out, and write my equation here. Y is equal to 1/2 times cosine of 3 of x plus pi 6, close it, and minus 1. Here we can start identifying our values. And our values are like amplitudes and trying to get more colors here. So let's start first that this is a positive function again. It's not always positive, keep that in mind. We have a cosine, so a positive cosine is like a soup bowl, like a cereal bowl, where it has kind of flared out edges, but we are able to put milk and cereal inside this bowl, okay, or soup. If it was negative, then the bowl would be flipped upside down. So here we have a positive cosine, so we're able to put soup here. Again, if it's negative, it would be flipped upside. Let's see if I can do it here with my shadow. Flip, nope, can't do it. Flipped upside down if it's negative. Next, we are looking at our A value. A value is our amplitude. We always want to take the absolute value of our A value. Then we are looking at the K value, and K value is your midline. We are looking at our H value. H value is our start, our phase shift. Remember, it's always opposite of what you see, so we're starting at negative pi 6 this time. And our B value is used to find the period. Okay, so 2 pi over B is our formula. So that means 2 pi over 3. No keep, change, flip here is going to be our period. Okay, 2 more items we need. We need our end value. End value is taking your period and your start, adding them together. Now in this case we are subtracting, but we still need common denominator, so I'm going to multiply this by 2. So you can keep it as adding a negative, or you can just put it as a minus. I'm going to keep it right now as adding a negative because I did say we're adding these values. So 4 and a negative 1, we get negative, just kidding, positive 3, 6, which we need to simplify to pi halves. This right here is our end value. Now, I want to point something out already, that if we take a look at our start value has a denominator of 6. We are going to need common denominators. So although our end value is going to be at pi halves, most likely we're going to use that 3 pi 6 temporarily to figure out what our other values are. But again, you can do it like we did in sine and just add at the end for your distance. Let's find our distance. Distance, we're taking our period of 2 pi thirds, always multiplying it by 1/4. So we go straight multiplication. 2 pi over 12 is equal to pi 6. Yeah. So now that we see our end value and our distance and our start wanting a denominator of 6, I'm definitely going to use that 3 pi 6 temporarily because I already have common denominators with my start. All right, let's go ahead and graph. Let's take a look at what we have. We're starting at a negative. We're ending here. I'm going to put this in a thinking bubble because that's what we're going to use. At a positive. Okay, negative, positive. Our midline is at -1. Okay, I'm happy I saw that. Our midline is at -1 with an amplitude of 1/2. So we definitely don't need positive y values. And we want to kind of stretch out where that 2 is on the y because we need to go up and down 1/2. Let's start with our start at negative pi 6. So let's guesstimate that that's here. So if this is pi 6, 2 pi 6, 3, hold on, 1 pi 6 is here. So 1 pi 6, 2 pi 6, 3 pi 6 would be here. This is our 3 pi 6 temporarily. I will go back and change it as our end. And our start is at negative pi 6. Dotted lines for reference. These are not asymptotes. These is just to help us graph. Okay, so this is what I mean by using the distance. So if I know the distance is pi 6, from here at negative to 0, And I'll erase this. This is your pi 6 distance. If I add another pi 6, I'm here. And if I add another pi 6, I'm here. And if I add another pi 6, I'm here. So using that 3 pi 6 temporarily will help us make sure that we have the correct values when we are adding for the distance. So we got 1, 2, 3 pi 6, it's good. Now, these are wrong. We do need to simplify. So this one will become pi thirds. And this one's going to go back to that pi halves that we said we would. Oops, pi halves, not pi 6, pi halves. Okay, now that we're here, we want to identify where a midline is. Again, we want to be a little extra with our distance between 1 and 2. So I'll take 1 here, I'll make 2 here. Negative, just kidding, negative 1. Not 2, negative 1. I'll even make negative 1 here. This is our midline. This was our start. This is our end. Okay, and then we're going up 1/2. So this is negative 1/2. And down 1/2. So this is negative 3/2. Again, the distance between your midline and your maximum value is your A. And the distance between your midline and your minimum value is your A. Okay, so we have a max, our minimum, our midline, our start, our end. Now we are taking a look at what kind of function do we have. Well, we had a positive cosine. Positive cosine is taking your C like a souple. It will hold things here, so that means that our max is going to hold our start and our end. Our start is on our maximum. Our end is on our maximum. And in order for this to be a souple, our middle needs to be on the minimum value, which means these two middles of the middles are going to be on our midline. Smooth curve, no sharp edges if it looks like a V. And I'm noticing how I'm giving that, souple, that C, a lip here. You want to do that as well, because these are not asymptotes. So we're going to curve back down, curve back down. Do not go past your maximum. If you accidentally go past your maximum, I will be removing points. If you go past your minimum, you are telling me that there are bigger values than the maximum if you draw above. You are telling me that there are smaller values than the minimum by drawing below, which is not true. Okay, so curve and arrows. Okay, let's go ahead and write some equations. I'm not going to do all of these. I'm just going to do one, and then you can do the rest. The way to check your answers is going to be on decimals.com, and then make sure that you are changing the settings on, oh, there it is. I did write it. Make sure you're changing the settings. Now this one is asking for an equation for sine and cosine, so you can do both from each of these. Okay, so this one's going to get a sine and cosine, and the other ones are going to get both sine and cosine. Before we do anything, let's go ahead and identify like the obvious ones. And I'm going to skip this one. I'm noticing that the middle of this is on 0. That's okay. I'll do this one, the one in the middle. Okay, so let's go ahead and identify your maximum and your minimum. Then we're going to take those values and cut them in half and find the middle. That's going to be your midline. Once you identify that, you're going to take a look and first select, are you going to write the equation first for sine, or are you going to write the equation for cosine? Make up your mind. Okay, make up your mind. I'm going to first write the equation for, let's do sine, because why not? So I'm writing the equation for sine, and the one that stands out for me, again, you can choose positive, you can choose negative. I'm going to choose a negative sign. And how do you choose a sine wave? Well, you're looking for 3 points. You want your start, your middle, and your end on the midline. Okay, that's going to be your sine. So I've chosen a sine. I did go down. So that means it's going to be a negative sign equation. Next, I'm going to pick out my start and my end for my sign, which gives us the period. Okay, that's your period. Now, what's really important is that period is not technically in the equation. It is with a b value. So I'm going to go ahead and put little stars here because this is super duper important. This is typically missed on the exam because you forget that you don't actually have period. What you need to do is use period to solve for b. So when you're solving for b, let's calculate what the period is. Now, I got lucky. I did start at 0 and I ended at 3 pi. So what is the distance? Well, 3 pi. So period is 3 pi, and the formula you're using is period is equal to 2 pi over b. This is the formula that we used for graphing. This is the formula that we're going to use for writing. So 3 pi is equal to 2 pi over b. I'm going to put a 1 underneath, and we're going to flip both sides. That means I get 1 over 3 pi is equal to b over 2 pi, multiplying by 2 pi both sides. I get 2 pi over 3 pi. Pi's cancel out. They undo each other, they divide. So b is equal to 2/3. And now we are ready to write our equation. For sine, we have y equals negative. Okay, what's our a value? Our a value is the distance from the midline to your maximum or minimum. So if I'm at 3, 4, 5, 6, that means my a value is 3. So we got negative 3 times, what am I doing? Sine of, what's my b value? 2/3 of x. What's my start? So my start is 0. You can always do opposite, not always do. You must do opposite of what you see. But because it's 0, I'm just going to write 0. Close it. What's our midline? Positive 3. Make sure to distribute. Obviously, this is 0. Apologies. Here we go. So we got 2/3 distribute. Now it's 0, so we are going to have 0 inside. We are going to remove that. So for my final equation, I get y equals negative 3 times sine of 2/3 x, no 0, plus 3. Now for cosine, we're going to find a function that starts and stops either on the maximum or on the minimum. Now the one that's standing out, I'm going to choose some that are not overlapping. It is okay to be overlapping. There's nothing wrong with that. But I'm going to choose my start here and my stop here. Oops. And in reality, I'm ready to graph. Now, the ones that I chose don't really have any pretty values. So like if I was to see what these values for my start and my end, I kind of don't really know what these are in order to calculate the period. But that's okay because the period distance, start and end for your cosine, is the same distance for your start and end of your period. So we already did all the hard work, okay? So we're ready to write the equation for cosine. Cosine starts in the maximum, so that means we're going to have a positive function, y equals positive. Our amplitude is still the same, 3. Our function is now cosine of, our b value is still the same, of x. Now our start, again, start is a little bit on the iffy side. So if we take a look here, I might have to change my equation if we don't know what that start is and do some overlapping. So let's see, if this is pi, this is half a pi, this is half a pi, right? So this is pi halves, 2 pi halves, 3 pi halves, 4 pi halves, 5 pi halves, 6 pi halves, 7 pi halves. So if we do by 4, it's 1/4, 2/4, 3/4, 4/4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 5/4. If this makes you uncomfortable that I'm calculating the start value by like counting, I'm looking at each tick mark. This is 1 pi-4, 2 pi-4, 3 pi-4, 4 pi-4, 5 pi-4, 6 pi-4, 7. You don't have to do this one. You can start here and here, okay? So this is negative 15 pi-4, so that means I cannot simplify that, but that also means that my start is opposite of what I see. So I'm going to do a positive 15 pi-4 here. Close it, midline was at positive 3. Let's go ahead and distribute this. Pi-thirds. Y is equal to 3 positive cosine of 2 thirds x. 15 times 2 is 30. 3 and 4 is 12. Yes, we do need to simplify that. 2 goes into 12 6 times. 2 goes into 3 15 times. So we get 15 pi 6 positive. Actually, we can simplify that more. What am I doing? So 3 goes into 6 twice, and 3 goes into 15 5 times. 5 pi halves. There you go. That's better. You did not have to choose the yellow and the purple. You could have chosen anything you want. Your equations could look different. Your answers could be different. That doesn't mean they're wrong. So please use decimals to check. Okay. And then the last one that I'm going to do is so we got 2 more sections on the no calculator portion. And the section on the no calculator portion is going to be the unit circle, which you should have that memorized in under 3 minutes. And then here we have our timed values, okay? So this is going to be very similar, 20 questions in under 10 minutes. And there's some positives here, some negatives. So because this is a practice, it is okay for you, obviously, for you to spend a little bit more time, but I am asking you to practice. We are wanting reference angles as a tool and also quadrants, okay? If you figure out what quadrant it's in and then what your reference angle is, it's a lot easier to solve these, okay? Again, there's not going to be your like calculators on this. This is everything that's going to be like based off of memory. So make sure that you have this. Okay, so let's go ahead and start. We got tangent of negative 240. Now, if you want to start by drawing out your angle, that's fine. This is negative. That means we're going down. Down 240, that means we're going 180. Then we're not going to 270, so we're going about here. We are in quadrant 2. In quadrant 2, all students take calculus, so you know your answer is going to be negative because it's asking for tangent. Now, what is our reference angle? Reference angle is the distance from our terminal ray to our x-axis. So this right here is our reference angle. From 240 down to 180, we're looking at a reference angle of 60. So basically what it's asking is what is tangent of 60 degrees? You can do 2 different things. So if you're here and you wanted to do your 60 degrees, which is 1/2 root 3 over 2, you can do your kind of like your keep, change, flip here, and then do that. But in reality, if you just have these memorized, I mean, it's going to be a little bit easier. So this is root 3 for your tangent of 60 degrees. So if we bring that value up here, this is your answer. Now, I don't need to see any of this. You can absolutely do this in your brain, draw the angle in your brain, etc. Okay, so now let's look at sine. This is again down. We're going down, negative. The trick for radians is you're looking, am I adding or am I subtracting by 1? But that's okay. We're going down. This is almost a full cycle. So a full cycle Sorry, not full, half. This is almost half a cycle. This would be 6 over 6 if it was half. It's not. So we're looking here at quadrant 3. All students take calculus. And again, we're looking for a reference angle. Here, reference angle. Again, for your radians on this sheet of paper, okay, it's a little bit easier to find your reference angle, in my opinion, because it's always going to be pi 6, pi thirds, pi fourths, pi 6, pi thirds, pi fourths. So if I traveled 5 pi 6 down because it's negative, how much more do I need to travel to get to 6 pi 6? Well, the reference angle then is 1 pi 6. So we're looking for sine of pi 6. Okay, so again, have your values memorized. Sine of pi 6, that is 30 degrees. We're looking at here. We got root 3 over 2 and 1/2 and negative, both, because it's in quadrant 3. And so that means we have a sine of pi 6, which is 1/2. Bring it up here, it is negative because it's in quadrant 3, and we got negative 1/2. Okay. All of this can be done in your brain. You don't have to show me work. If you wanted to draw out, again, you got 3 minutes for this. If you wanted to draw out a mini quadrant 1 and use that as a reference, that is absolutely okay. So like if I hand you this paper and you wanted to flip it over and give me quadrant 1, right? And then identify your values. So that way you know sine and cosine, cosine and sine. You can do that. I mean, it's going to take you, what, 10 seconds out of your 3 minutes? Sorry, not 3 minutes. This gets 10 minutes. So 30 seconds out of your 10 minutes in order to help you, you can absolutely do that, okay? Almost forgot that these questions are also part of your no calculator portion of the test. So my apologies. We're going to throw this in at the very end. All right, so what these questions are asking is to find the missing side lengths and leave your answers in as radicals in simplest form. So this goes back to IM2 when you were learning for your special right triangles. So what I recommend is somewhere off to the side, I'm going to do it above, draw out your patterns for your 45, 45 triangle and your patterns for your 30, 60, 90 triangle. Okay, so for your 45, 45 triangle, we have X on the side, X for the side, we call these legs. And then for the hypotenuse, we got X times the square root of 2. And this is a pattern you need to have memorized. And then for the 30, 60, 90, you have to be careful what angle, which side is your smallest, but which angle is your smallest. We always want to start off with X being your smallest side, which means that 30 degrees is going to be opposite your X for your smallest side and angle combination. Then we always know that hypotenuse is going to be across the street from your 90 degrees, and that's going to be 2x. And then that leaves 60 degrees here. I'll put it on the outside at x times the square root of 3. Okay, so now that we have our patterns, we're going to take a look at question number 1 here. On question number 1, they're giving us 2 letters, M and N. I'm actually going to ignore those. I'm going to scribble these out. I don't want them interfering with my work. Eventually, I'll go back. I'm using pencil, right, so I can erase that. But I'm going to go back and identify N and M, but right now they're not important for me. I'm taking a look to see what triangle do I have. I'm noticing I have a 45. Here's your hypotenuse. And so I'm going to start labeling it like my pattern. So I have 45 here, which means I have X, X, and X times root 2. And you're going to end up with this like mini equation. And for this mini equation, I'm going to go ahead and put it in a thinking bubble. We have 4 is equal to x. So now that we have this mini equation, we are going to solve for x. Now, this one you don't need to solve for x. X is already 4, so we got lucky with question number 1. Let's make this unblurry. And so we're going to then use x value for my other values. So that means I'm going to have a x here. I'm going to replace x with 4 and have my root 2. So then I'm going to erase or unhide my two letters that they've given me, which is N and M, and then write out my answer. So N is equal to 4, M is equal to 4 root 2. It's not always this kind of like straightforward, but for number one, it kind of worked out. All right, next we have, again, M and N. I'm going to scribble those out. I'm going to label my triangle. Again, here's my 30. Here's my smallest side, so that's x. Then do your hypotenuse at 2x. Then whatever's left over is x times the square root of 3. Again, here also kind of worked out for us. Not always the case. Sometimes you have to multiply, divide. So that means here's my mini equation. X is equal to 5. So that means if I go ahead and replace x here with 5, I get 5 root 3. And if I replace x here with 5, I get 2 times 5. Okay, so let's go ahead and erase what they are giving us, the two letters, and write out our answer. So we have m is equal to 5 times 2 is 10, and n is equal to 5 times the square root of 3. Okay, let's go ahead and do one more. This time they're giving you x and y, especially when they're giving you an x, be very careful. So I'm going to scribble these out, label. Okay, this is 60 degrees, so be careful. We always want a smallest side to be our x. So here's our smallest side. That means this is 30 degrees. Here's our hypotenuse, which is 2x. And then whatever's left over across from 60 is x times root 3. Again, so let's go ahead and do our little mini equation. We got very lucky with these three. I'm not very happy about that. So we got x is equal to 2, which means if I replace x with 2 and x with 2, careful, this one, it's 2 times. I'm left with, again, let's erase, because I want to know what they want. Now, this is where I'm saying, especially when they're giving you an x, you want to be really careful, because this x and this x are different, okay? This x right here is 2 times 2. So their x is equal to 4, not mine, right? Not the pattern. They're labeling A, B, C, D, N, and M, X, and Y. So their x is equal to 4, and then their y is equal to 2 root 3. Okay, I'm going to draw one in. We didn't really have one that made us struggle a little bit on finding what x is. So let me go ahead and make one up really quick. So let's do one with 45, 45. And let's make the hypotenuse 4. Okay, so how would you solve something like that? Well, again, we're going to go ahead and start out exactly the way that we did. I'm not giving you x's and y's. Should I? We'll do n and m. Just to be kind of similar to what the questions are going to look like. Let's go and scribble out that n and m and start out with our pattern. We got an x, x, x root 2. So when you get something like this, notice that when we make our mini equation, it's actually not just x, right? So we're going to have to do a little bit of solving to find what the x value is. And this is what I really wanted to show you. So what you're going to do is you're going to do a dotted line. And this is just multiplying the square root of 2. So I'm going to divide by the square root of 2 on both sides. Bring down the x. Here we have 4 over root 2, which means that we need to rationalize the denominator. To rationalize the denominator, you're going to multiply square root of 2, top and bottom. Okay, we got 4 root 2 in the numerator. 2 times 2 is 4, square root of 4 in the denominator. Here. And then we got to simplify. So the square root of 4 is 2. And one more time, simplifying outside with outside. So these two can simplify. So we get our final answer for x. Okay, 2 goes away. This is 2 is 2 root 2 for x. So then we would write this in 2 root 2 here, 2 root 2 here, and then we would then erase our little scribbles to see what letters they actually wanted. So for this one, we would have n is equal to 2 root 2, and m is equal to 2 root 2. Okay. And again, I'm going to do one more. So add these into your notes, please, your practice, because put a little star. This is very important. Just bad luck with the generation of questions from the computer. Okay, and we'll do, what number are we? 1, 2, 3, 4, 5. Let's do a 30, 60, 90. Here's 30 degrees. Here's 60 degrees. And we'll make this one into, I don't know, let's make it into a 6. Okay. Again, let's just assign these m and n. I know we're going to be scribbling them out because right now they're not really important. What is important is our labeling. So start with the smallest side. That's going to be your x. Your hypotenuse is going to be 2x. And then your 60 degrees is x times root 3. Go ahead and set up your little mini equation. So we have x times root 3 is equal to 6. We're going to divide by the square root of 3, divide by the square root of 3, and rationalize. Multiply top and bottom by root 3. X is equal to 6 root 3 over 3. Simplifying that, 3 goes into 6 twice, so 2 root 3 is my x value. So then I would bring in my x value here at 2 root 3. Here I need to replace the x value by multiplying by 2 root 3. So what would be my m and n values? M would be our 2 root 3. N would be 2 times 2. Both are not in the radical, so 4 root 3. All right, beautiful people. Now that wraps up the no calculator section. Thank you for watching. Goodbye.